Okay, chapter 19, day 2 video. We're going to finish out this chapter by working backwards a little bit. So sometimes people would like for you to go out and get information. And they might say, I'm really curious as to what proportion of people want to vote for me to be president. But they're going to put some parameters on you. And they're going to say, I want you to be this confident, but I only want this much error. For example, I want to be 95% confident, but I only want 3% margin of error. Well, with those parameters, you're going to have to sample a certain size. Only a certain sample size will give you that amount of error, because we know that error changes with sample size. So, today's question is, how large of a sample size is needed for a given level of confidence and a given margin of error? So we know the confidence level and we know the amount of error that we're willing to allow. What we're trying to do now is how large of a sample size, which we know the sample size is n. How large of a sample size n is needed, okay? Well, okay, so first thing, let's recall something, all right? The margin of error is that part that comes after the plus or minus symbol, because we have our p hat plus or minus the margin of error. So we can go up or down from the p hat. That is the z star standard error, okay? Now, standard error in general is p times 1 minus p over n. Okay? When we did the penny experiment in class, we used p hat because that was the proportion we got from the pennies. We didn't know the true proportion. We couldn't use the true proportion there. Do we have p hat on this one? We don't even have that, because we haven't gone out yet to do the survey. We're trying to figure out how many people to survey. And so in this case, since we don't know the p or the p hat, we're going to use 0.5 there. That number 0.5 gives me the highest product. 0.5 times 0.5 is the highest product. Gives me the most leeway. We will use 0.5 for these numbers. Okay? Unless we have previous information, unless we already know some previous statistics. For example, statewide statistics show 80% of the people wear their seatbelt. I wonder if that's changed now in the past 5 years. So I want you to go out and do a survey for me. I want you to be 95% confident. I want you to be margin of error of 3%. Well, I'm going to use the previous known information about seatbelt use, and I would use 0.8 and then 0.2 here instead of 0.5, because I have some previous information about this situation. So, since we don't know p or p hat, we're going to use 0.5 in this formula, unless we have previous known values. And so because of this, we change this letter not to p hat and not to p, but we change it to p star. Okay? So we're going to use this for p star. So standard error now, instead of p, we'll have a p star here. Z star, that's from our level of confidence. P star, again, is going to be 0.5 unless we have previous information. Now, out of all of these pieces, these we'll know or use 0.5. This we will know because someone's going to say, I want 95% confidence. Well, we already know that that's going to be 1.960. They're going to say, I want 3% error. Well, that's 0.03. I want 4% error, 0.04. Okay? And so basically, we need to solve for n. Now, there's some symbolic manipulation we can do that if you just remember the end result, you don't have to do. So it's up to you. but I'm going to go through it anyways. We know we can break a square root down into two separate square roots. We learned that in Algebra 2 Trig, or intermediate. We know that we can multiply both sides by the square root of n and divide both sides by m, and essentially those two just switch places. And to undo a square root, we are going to square both sides. So our new formula right here is the sample size that we need for a given confidence level, a given margin of error, and then P star again is going to be 0.5, or if we have previous information, we will use that decimal instead. One thing to note though, to make sure that we meet the minimum sample size needed, we will always round up to the next integer. So I don't care how low the decimal is. It could be 130.005. We would round up to 131 because we want to make sure at least we get the minimum needed. So here's an example. How large of a sample size is needed for a 95% confidence interval and a margin of error of 3%? So I start listing, what do I know? My P star, I don't have any previous information. I don't even know what the context of the problem is. P star is 0.5. Margin of error, we have to write it as a decimal, 0.03. Z star comes from page 880 out of the book again. That's 1.960. And now, plug and chug. Take this formula, 1.960, square root of 0.5 times 0.5, 0.03 on the bottom. Take this whole value and square it. I got 1067.1, but again, round up, 1068. So if I want to be 95% confident about anything with only a 4% error, or a 3% error, 3% error, I need to talk to 1,068 people. So if I'm a presidential candidate and I want to be 95% confident about my interval, and I only want a 3% error, and again, some of you have talked about this, you see on the corner when they state the presidential runnings or the results, they'll say plus or minus 3% or 0.03. That's what they're talking about. They must have sampled 1,068 people. Well, I already know how many people they sampled. So I could go get those people as long as they're representative sample. I could pick them from any state as long as they're representative. And I can get information about the whole country. 1,068, that's all it takes. And that's it for day 2. So when you come back, we're going to do problems finding sample size needed as well as more confidence intervals.